So hi all, good morning. So our first session today by Priyanka Nag. Did you enjoy it all? Why so low response? Means I was sleepy kind of? Okay. So what we are going to see today is architecting design decisions. The first question that I want to ask you all is, why architecture? We take so much architecting design decisions. We decide, okay, we should have somewhat like this list, we would use model view controller, or we would use task-based UIs, or something like that. We always take decisions on architecture as developers. So my prime question is, why architecture? Why do we need to care so much about architecture? Why is architecture so important? When I used to converse with some of the developers, I asked them, why do you decide about architecture? One answer what I would get is, they say that scalability, our application should be scalable, our software should be able to scale effectively. I would say that's an answer, but everything has a cause and an effect. So I would say scalability is the effect of the cause. We have not found the cause. We should actually find what is the actual cause that we should take care about architecture in a software application. We should go and find the answer to that question. To find answer to that question, let us come a step back. We should understand our objective. Why are we exactly here? Not in this Joomla World Conference, but as a developer, why are we here? What is your prime role? I feel we develop applications, but why? We have to understand the why. The answer to that, according to me, is to cater to businesses' needs, to give solutions to organizations' business needs. That's the only reason we develop applications. We are here because our software goes and solves business problems. They directly affect how a business grows. They directly they have a say in the growth rate of an organization's, the say in businesses' growth, the growth rate. So that is the prime reason why we should care about architecture, because if our product fails, businesses fails. That is what the cause is. That is what the effect our products make. So we have to very much care about our architecture. Screaming architecture. This was a term I came about like a year back. I was reading a blog and I came about this term, which actually gave me a sense into what our application should be. Suppose let's take an example of a building, your house, your own house. When you have when your house was going to be built, it was constructed, there would be some architect who was drawing the plan of the building, if I'm not wrong. Do you agree all that? There must be some architect who was drawing the plan. So in that plan, what was the major role of that architect? What would he show? What would we see? We would see like there must be some kitchen, there must be some living room, there must be some bedrooms or some play area, something like that. Every architect's plan in a construction of building always shows this, living room, kitchen. This is what the architect's plan scream. This is what screaming architecture is. We have to know what our applications scream. Do they scream inventory management system? Do they scream accounting management system? Or do they scream Joomla? Do they scream Laravel? Do they scream Ruby on Rails? What do they scream? An architect's plan never screams bricks or the cement or the tools that we use. It always screams about the domain. It always screams about what's the use case, not about the tools that they are using. The same way our applications architecture should be screaming about the domain, not about the tools that we use, like Laravel or Ruby on Rails or some ORM that we're using. That's what an important architecture means. That's what our architecture should always scream. So MVC, this is the default industry standard that I see every day nowadays. Like any web application you take, I ask question to any of the developer, he says, I'm doing MVC, I'm doing a good work, I'm doing MVC. I would say yes, MVC is a good solution to problems, but it is not good enough to all the problems. When MVC was developed, it was defined to solve a set of problems which were arising at that point of time, and that were typical CRUD problems. You would have some forms which were directly mapped to databases, and MVC would be useful to do a quick insert, update, or CRUD applications to databases. But what we face today is our applications have very complex business logic. The domain logic is so vast and complex that fitting it into MVC is not a solution. MVC is not a solution to each and every problem that our web application faces. But everyone is throwing MVC as a solution. I see many developers going around and taking some other solutions, But majority of them feel that, okay, my all logic has been divided in MVC. My model contains all the domain logic, my view contains presentation logic, and my controller contains some routing and application logic. This is what I hear nowadays. But no, this is not the case. The domain logic is so vast that putting it into model is not enough. Our domain is widely and very complexly related with our presentation, and we need to find some other solution. We need to find some other design patterns to actually go and solve those problems. That is what is needed. This is a typical separation of layers that we see today in MVC. We would be having one presentation layer where we would be having some controllers and views. The controllers would do some routing and views would be enabling the presentation. Then we would have some storage or data layer which would have some ORMs or some repositories which would be talking with our databases, and a service layer where we would generally keep our validation, mailers, or some part of business logic. But we also keep major part of our business logic in our repositories. So this is what a general advanced based MVC architecture looks like nowadays in majority of the frameworks or any applications you go and see into. When we see the code for the same, we would see something like this. Suppose there's a controller which creates a task. It would have a function by the name create task, and it would do such type of sequential task. There would be a validation service which would validate the request. There would be a repository which would be creating the task using some ORMs or something like that. There would be a logger, any logger that you have, it would be logging the info. And once the task is created, we might also need to send a mail to this user. So a mailer service is present which actually comes and sends the mail to the user. So what is exactly the problem with this approach? Means I see this is okay, there's 4 lines of code. What is the problems? I would say that there's too much of logic in one function. Why the hell is our controller aware of sending a mail to the user? It is not the responsibility of the controller. Why our controller is aware of logging the info? It is not the responsibility of the controller. Today we are mixing up responsibilities in each and every layer. We are doing some things in controller which shouldn't be done in the controller's logical area. That is not their responsibility. We are mixing up responsibilities so much that we tend to do everything in something. We are violating SRP and OCP. And any of you know solid principles? Means I suppose most of you must be knowing. So single responsibility principle, open close principle, these are the heart of how to design an application. They are guidelines which we should use, but we are seriously violating those principles. As I said, we are doing things that are not the responsibility of controllers. There is no separation of concerns. At the end, why do we need to think about architecture? As I said, because if our product fails, businesses fails. And as businesses evolves, idea also evolves. Change always comes. Change is the only constant in a software. Change will always come to you. You should be equipped to manage change. That is what maintainability is all about. We should be able to build on what we have. That's what our teams are equipped to. That's why businesses trust in us, because we would be able to build on what we have. And that is why architecture is important. If there is no separation of concerns, changing a functionality is too tough. It would lead to produce bugs in some other part of application as well. We would mix up some things. We have to do, we would not be doing dry, we would be doing wet code. We have to follow dry code if we really want to be able to maintain applications. So, if coming down or boiling down to the problem, the real problem is no separation of concerns. I mean, there is so much of logic that we are not able to separate the concerns in different parts of our application. So let us first understand what is the responsibility of our different layers. That if we understand that, we would actually know what to keep where. So what is the general responsibility of controller? I feel a controller is responsible for these 3 responsibilities. The first one is to retrieve a request. That's it. A controller will retrieve a request. It might be from it might be an HTTP request, it might be some other kind of request, but controller should be able to catch the request and pass it on to a service layer. That's it. It takes the request and passes it on to the service layer. It shouldn't be concerned about what to do with that request or what logic to apply to actually process that request. It will just catch the request and pass it on to the service layer. The service layer will do a set of sequential tasks which it will like migrating it to the database or doing some processing some business logic or something like that, and then controller will create a response and display it to user. The response can be in a form of a view, it can be form of a JSON, it can be in a form of a CLI response or something like that. but that's it. If we condense it, retrieve a request, pass it onto a service layer, and then create a response and display it to a user. That's what controllers should be concerned about. Nothing more, nothing less. Your controller should never be aware of any type of logic or persistence. Most of the time we call repositories or we simply write database query builders or some ORM stuff in our controllers. So your controller is aware of persistence logic, of your data, how your data is stored. So that is not the responsibility of the controller. Your controller should never ever be aware of any type of logic or persistence. When I used to study this question always popped up in my mind. Where does the validation logic go? Where does the mailers logic go? Where does the business logic go? Means these are very different types of logic, and to handle them in different layers, it's pretty tough task. So where does all this go? I would say they are differentiated into service layer and a business layer. So a common solution that I found around this is a command-oriented architecture. I came across this when I was trying to develop applications in a good way, in a good design, so that they are maintainable enough. I had to develop like a few months back, I had to develop an application wherein I had to expose it to an API also, and I had to have a web application as well. And at that time, command-oriented architecture helped me a lot. So we would be actually seeing what command-oriented architecture is and how it can be useful in actually separating our logic. The key points of command-oriented architecture are these three things: commands, command handlers, and command bus. These three things constitutes the whole command-oriented architecture. It revolves around all these three things, and we would see what they are one by one. So what are commands? Commands are simple DTOs. Commands are simple DTOs. What are DTOs? DTOs means data transfer objects. That's it. The responsibility is to only contain information. So if you have some command, it will have some data and will only contain that information about some data. It will not do any type of logic nor any processing, nothing else. It will just hold that data. That's the only responsibility of a command. It is a data transfer object. Command handlers. Command handlers are another part of command-oriented architecture, and the responsibility is to perform sequential tasks by communicating with service layer or storage layer or whatever layer that we are using. So there's a term called as commands, there's a term called as command handlers. Commands only contain data, they have information, and there are command handlers who does the logical part in an application. And as I said, commands are data transfer objects. They will transfer this data to handlers when they want. So commands carry information and they transfer this data to the command handler whenever they are requested. So if we see in an essence, it would be something like this. We have a command in a presentation layer, we will be having a command handler in a service layer, and there will be something which would be transferring the data from command to the command handler, and that is what we call a command bus. So if we say there's a command that is present in the presentation layer, there's a command handler in the service layer, and there's a command bus which helps to transfer the data from command towards the command handler. If you see in the layered structure, this is what it would look like. We have commands in the presentation layer, like most of them would be in the controller part. Controllers will be dispatching the commands, and those will be cached by the command handlers. Those will be handled by the command handlers in the service layer. So let us see a quick example of how this actually works. Suppose we have a create task command. We want to create a new task. That's a basic task that an application can do. So we'll be creating a new task, and it will be having a create task command. I would be initializing the command with two parameters. So let's say there's task name and due date. One thing that we take care here is a bit of validation logic. I will not say that it takes total care of validation, but commands have in themselves only perform some basic validation like required field. So this can be very much useful in validation stuff as well. We will initialize both of these fields in our command. So this is what our basic command class looks like. That's it. It is a data transfer object or a data content. It only contains information. There is no logic. When we initialize a command, it has two parameters which are initialized in the command. That's it. It just contains information. If you see it very clearly, that's the only responsibility, and that's what it is doing very effectively. Then let's take an example of handler. Every command has a corresponding handler. The general naming conventions that we follow is we append the handler keyword in front of the command. So what we had is a create task command, and we had a handler by the name create task command handler. It's the general nomenclature that we follow. This is the constructor of a command handler. Now this is a bit complex. I have injected some dependencies in my handler which are task repository and mailer. So anybody of you are aware of dependency injection here? Anybody? Okay, 2 of you. I would say dependency injection is like when we naive up in a constructor, we mostly naive up a class when we have some dependency, like my command handler is dependent on mailer service. So what would we generally do? We would like write something like $mailer equal to new mailer in our constructor. But what happens is that dependency goes onto the command handler class. So in dependency injection, we pull up that dependency in the constructor and we inject those. Now this would be afterwards injected dynamically by my IOC container or whichever container that you use. I mean, this is a bit complex stuff if you are not aware of dependency injection. I would not be discussing dependency injection now in very detail, but we would surely, if you have any doubts, we would surely get to know it after the talk. We can surely discuss about it. But what I would say about dependency injection is, instead of naiving up the dependencies in the constructor, we pull them up in the constructor as a parameter and we inject them. Then there is some IOC container, inversion of control container, which will dynamically put those dependencies whenever a command handler is initiated. That's what an IOC container does. So this is my basic command handler class. It has 2 dependencies, repository, my task repository, and my mailer service. Then there will be one handle method. Now this handle method has another dependency, and that is create task command. If you see, in my command handler, I had 2 dependencies, mailer service and a task repository, which I would be using to do some sequential logical tasks. And my handle method has a command as a dependency. This handle method is totally responsible for following or carrying out all the sequential tasks. So let's take a recap. I have a command with the name create task command. I have a command handler with the name create task command handler. Whenever a command is initialized, it will contain the information, and my application will dynamically go and call the handle method of my command handler. Do you get it? I have a command which is when initialized, my application will dynamically go and call the handle method of my command handler. And this all stuff is carried out by the command bus, the glue between command and command handler. Command bus has all the logic which calls or dynamically does all this update. Now let's see what we can have in our handle function. So my sequential task, my task repository, I will call a function for my task repository for creating a task. Then I will pass it some parameters like command name and command due date. So if you see, I have a dependency of command object wherein I can take the information from the command object directly and insert it into my function as a parameter. My handle method, I call task repo to create a task, and I pass in the information from command into my task repository as parameters, which will then go and create a new task. After then, if I want to send mail, this is an event which is triggered. So if I want to send mail, I will send a mail to the user and it will perform, the mailer service will perform whatever it wants to. So this is how my command handler looks like. I have a command handler with multiple dependencies in my constructor, that is constructor dependency injection. I have a handle method with my command as a dependency, and if I want to make a task, I want to create a task, my task repository will be used to create a task, and I will be passing the information from my command. This is what my general code would look like in a command and a command handler. So we have pretty much done what a command and command handler is and how the logic goes in there. So let us go and see how do we actually dispatch those commands in a controller. We have a controller, right, which accepts requests. So we need to be able to dispatch those requests from the controller. So what would it be there? There would be some function like dispatch. Now this would be another abstraction layer which we would be having as an application. There would be a function which by the name dispatch which would actually dispatch the command. So what would it do? This is what the general function would look like. In my controller, I will dispatch a command. The command name is create task command. So in controller, whenever I get some request, I will dispatch the create task command, and dispatch is what is, I can say, is calls the command bus, which actually goes, takes the command and maps it to the command handler. I know it's a bit of complex to understand this at the code level, but this is what actually it looks like. We will just go out and summarize everything. I have a command, I have a command handler. Command is always mapped to its corresponding handler, and whenever a command is initialized, the corresponding handle method is called. This is what a command and command handler is. There's a stuff in between which is called as the command bus, which actually connects the command and command handler. In a controller, whenever I want to dispatch a command, I would be having some logic, some abstracted logic or some function which when called, it will dispatch the command into the command bus. Then command bus will map that command to the command handler and execute it. That's what it is. So if we see it in this view, it would be something like this. At presentation layer, I have a create task command. At service layer, I have a create task command handler, and there is a command bus which maps both of them. Okay, we have understood what command and command handler is, but what exactly is the use case of using this command oriented architecture? Means only for the sake of doing it, we shouldn't be doing it. We should be doing some architecting design decisions if there's some use case for it. Let's take an example. I have an application which resides on web. Say for example, inventory management system. I have it which resides on the web. I have some multiple mobile applications like iOS and Android devices which actually talk with my application. So my inventory management system has an API, it also has a web application. And I also have a CLI layer or a command line interface application to actually internally create reports which are also available on web, but I want something on for cron jobs or something like that. So it also has a CLI layer there. So what is all this? This all is recurring logic. If I see what is an API, CLI or web does, it has same kind of task. What your API does of creating a task has same type of business logic. Whenever you create a task from your web application, it has same type of logic. The difference is in the request and the response. In web, you get a request from a browser, like you type in a URL. It is an HTTP request. In an API, you get a post request, it is also an HTTP request, but it gets in an XHTML form. The response is different. In an API, you might give a JSON response. In web, you might give an HTML response. The type of request and the type of response are different, but the business logic is same everywhere. So what is different exactly is controllers. There would be an API controller, there would be a web controller, but there would be only one single command, and that is create task command. All of these controllers will finally go and call the command. That's what it is. We have different controllers, but they all have same business logic, and this is how we map it to a command. So we have separated our concerns. The main concerns are request and response. We have separated out them in API, CLI and web, but the main business logic is same. So we differentiate out in the command, and our controllers call them. Let's get to another part, events. What are events? Events are also DTOs, as I said, data transfer objects. Now we are moving to another part, that is events. Events are DTOs, or we can say data transfer objects, same as commands, but they do a different job. They are useful for a different job in an application. Let's see some example of events. User registered, post liked, user tagged, password change. These are simple events in an application. When they happen, user logged in, that is an event. New user registered, that is an event. User tagged, that is an event. What does exactly happen for events? There are events which are fired in an application. User was tagged, user was registered, email was sent. This is an event, and they are generally fired, and they are eventually caught by listeners. Events are fired, and they are eventually caught by listeners. Listeners would be like this: user was registered, post was tagged, password was changed. These are some examples of listeners. So if I see, events are fired and they are eventually caught by listeners. So what do listeners do? Listeners then dispatch services. Events are fired in an applications, they are caught by listeners, and listeners then dispatch services. So how is this exactly useful to us? Let us see that. So this is our command handler. I will come back to our command handler that we have created some time ago. This is, everyone okay with this? There's an event in here, task created event. A task was created, that is what an event was fired. So what I would do is, I would be needing a listener. So I would just cut out my mailing stuff, because it is a response. Sending a mail is a response to an event, right? My task was created, so my mail was sent. So sending an email was a response to an event. That task was created. So for now, I will be shifting it to a listener, so I will cut it out from here. Currently, my command handler would look like something like this, and then I will fire an event. If you see, I had a task created event here, and then I will fire an event. That new task was created, and I will pass on the task object as a parameter to that event. And then that's the responsibility of the event, to either send an email, to set up some cron jobs, or to log the info, or something like this, to set up some reminders. That is the responsibility of that event. We don't have to be concerned about that in our handler. That's what events are useful for. So it is something like this. Task created event is fired, then it was caught by task created listener. Now this task created listener has the responsibility to whether send an email, to log info, or set cron jobs. It is the total responsibility of the listener. Controller or commands or command handlers shouldn't ever be aware of that. So let us have a recap of what clean architecture looks like. It is generally independent of frameworks. As I said in my screaming architecture, your architecture should never scream about what tools are you using, like Laravel or Ruby on Rails or some frameworks or some ORMs. Your architecture should always be independent of frameworks. It shouldn't be ever saying anything about tools. It should be saying about your domain, that is inventory management system, about accounting management system, library management system, whatever you are building. It should be testable. Your architecture should be testable independent of your frameworks. It shouldn't be dependent on any persistence layer or something to test it. It should be testable. Independent of UI. Your presentation logic should never be dependent on your architecture. Your architecture should be independent. You can anytime change your UI and your architecture will still be stable. It should be independent of database. So what does it exactly mean? As you said, we had a repository. You should be always be able to swap your databases. Currently, we are using MySQL. So having a repository, tomorrow you can just use PostgreSQL, or you can just use Microsoft SQL, or some other type of database layer which you want to, or some other type of ORM layer you want to. You can shift to a NoSQL database. Your controllers and other commands and command handlers shouldn't be changed when you do that. Your architecture should be independent of databases. That's what clean architecture generally means. It should be independent of external agencies. Any third-party applications or third-party dependencies that we have, it should always be independent of that. It shouldn't be directly dependent on that. We should be able to swap each and every service, each and every layer that we have without actually conflicting with any other thing. So clean architecture would seem something like this. The main thing that we have is entities or our domain, which should be present in which should be the center of our architecture. The use cases should be surrounding them. Then comes the controllers, gateways, and presenters, which are like pipelines or input points or output points to our devices, web, API, external interfaces. They can be changed anytime. They are like, the use cases are input points to our inner architecture. And each of these layers should be swappable at any point of time without ever causing any change in our application. That's what clean architecture is all about. That's of architecting design decisions. A bit about me. My name is Viraj Khatavkar. I'm co-founder and head of technology at Tantragyan India Business Solutions. We are situated in Mumbai, India, and we primarily deal in PHP services and UI UX services. These are our primary offerings. Other than that, we have Joomla services and WordPress services as well. That's the logo on the right hand side, my company's logo. Our tagline is towards empowerment, and it is like two hands catching each other, and we are empowering each other. So that's what it is. You can anytime contact me at viraj@tantragyan.com or I tweet @virajkhatavkar. So that's it. That's about me. Thank you. Any questions? Yeah. No, it's not. But as I had some discussion with Chris and I forgot your name. Sorry, Marco. It is there in plan for Joomla 4, I suppose. And Joomla 3.6, they are going to try it in alpha version, if I'm not wrong. Chris had a good presentation about that yesterday evening. I don't remember, Joomla for architecture was the session's name if I'm not wrong. Yeah, he had a great presentation there regarding that, how it's going to be implemented in Joomla. Anything else? Yeah.
The architecture is definitely a good thing because it streamlines how things work under the hood.
Yeah.
One concern I have is the more you add into the architecture, the performance gets affected.
No,
So
it's sorry for direct response, but I would differ in that way because our architecture plans for that things. For example, if I take command handlers or commands, my commands whenever performance affects is when I have too much of request doing the same, dispatching the same commands. That would be a performance issue for me. So what I would do is I would queue my commands. There's a queuing system that I would implement. What it would generally do is whenever a command is dispatched, our application wouldn't go and directly execute it. It will put up in a queue and my queue will be processed simultaneously differently in an application. So my execution goes on going and my architecture gives me leverage to actually queue my classes or my execution systems. But if I had the same logic directly in my controller, I wouldn't be able.
No,
I wouldn't
I'm
be
not
able to
saying
queue
it's
it.
going to be in the controller. Traditionally, the way we implement it is whatever logic you have presented, it will be in the model. Controller is going to only trigger the model.
No, in this architecture, it's not.
No, but it could be designed like that. I could simply call the model, and the model will take care of doing all the things required of the service layer.
Yes.
Right? It will send the emails. It will trigger any other action that may be required.
Yes.
Now you are adding an extra layer of command handler, and stuff like that. So this extra thing comes into the pipeline. So that is the reason why I say, is there a performance trade-off?
I will solve you with an example. Suppose you have a controller of creating a task. You will call a model. In a model, you will send an email. You will set up some cron job. These are the two tasks that you would do in a model, right? So whenever you do this, what happens is these two tasks are bound to be executed. You can queue them otherwise, but these are bound to be executed. In a command and command handler, I get to handle them very separately in a separate class, and I can actually queue that class. That is one solution. Another thing is that this sending an email can be triggered by an API controller as well, or by something else in the system as well. So whenever I want to change this logic, I have to go into each and every model or each and every class that I want to change, and this would also be very much I'm not getting the word, very much tiresome for me. So whenever we have this separation of concerns in different classes, I have to just change at one thing, and my architecture will take care of the rest of the things.
Okay, we'll discuss offline.
Sure, no problem.
The only thing I mean, I don't know, maybe others also have felt it. I was traditionally using Joomla 2.5.
Okay.
And when I moved to 3.5, I saw that my sites were very slow.
Okay.
Right, because I have a very old laptop which is running only single core, 1 GB of memory. So 2.5 was running smoothly on that, but when I start to develop applications for 3.5, immediately I noticed there's a performance issue, which you will not notice if you are using the latest laptop with quad core, as an example. So that is the reason I made the point that the more you introduce into the architecture, you are going to affect the performance.
Okay. I would say that that's a different issue, but we have to tackle it in a way like what's the actual problem, design problem there. Then we can actually tackle it. But yeah, we would discuss it afterwards. So if nothing's there, I would stop. Thank you for coming. I hope it was good for you.